Today we're starting a new book, moving straight ahead. So we're going to start with 1.1 notes today. Today we're focusing on a question that says, what equation represents the relationship between the time and distance you walk at a constant rate? What are the dependent and independent variables? So for vocabulary today, it says linear relationship. A relationship in which there is a constant rate of change between two variables. Linear relationship. A relationship in which there is a constant rate of change between two variables. So in part A, it says how many seconds did it take you to walk 10 meters? To save us some time, I will give you this first one in seconds, just to save us some time so we can go on throughout the rest of this in converting. For the first question, how many seconds? It takes 5.53 seconds for you to walk 10 meters. So now that we know that, it says, what is your walking rate in meters per second? We know we want meters per second here. Meters per second. It says, what is the walking rate? Well, we know that we have, how many meters? How many meters do we have in this? Well, 10 meters. So I can put 10 here. I'm going to put my M with it for meters. And then, Sophia, what else am I going to have? Thank you. 5.53 seconds. Meters over seconds. So, to find how many per meter, Aiden, what am I going to do? Yeah, you can use calculators on this. If you need one, you can grab one real quick. You're going to divide that, though. This is 5.53 seconds per 10 meters, but I only want 1 meter. So I can simply divide this to get my answer. What other way could I set this up? There's another way when I'm comparing meters per second. Stephanie, do you know another way we could write this? Very similar to what we just did. We just didn't write it out. We have 10 meters over 5.53 seconds. Can't I have it equal something? X. Okay, where am I going to put my X? On the top. So I want to know how many. And then what on the bottom? Yeah, it is seconds. How many seconds? One. So for this, I would just do my cross multiplying, multiply those, and divide it, which is basically what we're doing right here in the green. So when I divide this on my calculator, now that you guys have calculators, what do I get, Eliana? Okay, so right here it says round to the nearest tenth. Thank you. Yep. So 1.8, I can write out meters per second. Or like I wrote in the green, M/S, that is also okay. You could write out the full words, meters per second. Or in the green, you can just write M/S, which means meters per second. Hand on your head if you're getting this part. Hand on your head, everyone. If you don't, okay. Okay, so let's go on to part D. Assume you continue to walk at this constant rate. That is my constant rate. How long will it take you to walk 500 meters? Okay, so we know our constant rate. We just divided it. I'm going to keep my constant rate here. And they told me how many meters Isabel? 500. So if I were to write this to cross multiply it, how would I write this out on the board? I have 10 meters over 5.53 seconds. And they told us how many again, Isabel? 500 meters, right? Yeah. Exactly, yes. Meters over x seconds. So again, to find my x, how would I do this, Maria? Exactly. Exactly. So, you cross multiply. I'm crossing it and multiplying it. So like Maria said, we multiply 500 meters times 5.53 seconds. And then we're going to take that answer and divide it by our 10 meters. Which in that case, Elena? 276.5. Thank you. So, in that answer, 276.5. And they said, how long will it take you to walk 500 meters? It's going to take us that in seconds. You can write just, or not seconds, meters. Sorry. Meters. So I can write just meters, or if I want, I can just write M. Both are sufficient. Either way. Oh, yep, you're right. I was right the first time with it. You guys are right. Thank you. It is seconds. I was looking at the wrong line. That's what I get for going fast, huh? So on 2A, it says, how far could you walk in 30 seconds? Well, they told me my seconds. And again, what is our constant rate of change that we're going to stay with, Blake? 1.8 meters per second. Right, and how do I write that as a ratio? It's 1.8, but how did we have it as a ratio again? Before we got it to be 1.8, what did we do? 10 to 5. Exactly, so that's my ratio. 10 divided by 5.53 seconds. So I'll show you two ways to do this. And Blake, how many seconds did they say in this question? 30. 30. So I'm going to keep my 30 down here, 30 seconds. And I want to solve for my x. Okay, well, we know how we can do this. So, what can we do to solve for x? Yeah, thank you. Multiply that. Cross multiply it. 10 times 30. And then we're going to divide it by this number. And like Blake was just saying, our 10 over 5.53, when we converted that, when we divided it, we got 1.8. So technically, we could have done 1.8 seconds. And we can multiply that by the amount of seconds they gave us here. We can do that because these are both in seconds here. 1.8 meters per second and 30 seconds. So, cross multiplying and dividing or multiplying this, both is the same thing. It's just written differently. So when I do this, it would give me 54 meters. Yeah. Okay, so to do that, you wouldn't, I think you got lucky with the same answer, but you have to make sure that your seconds are on the same side and your meters are on the same side. If you multiplied your 30 times your 5.53, did you have it laid out like this? Did you write it up like this? Did you have your 30 seconds up here? Okay, so do we have any more questions on 2A? No questions? So let's go on to 2B. How far could you walk in 10 minutes? 10 minutes now. Before we were working with seconds, meters per second. Now let's work in minutes. Well, I will tell you that in 10 minutes, it's 600 seconds. Does that help you out? I'll tell you that conversion. Now that we know that 10 minutes is really 600 seconds, we can figure this out, can't we? We can do some converting. So how can I determine how far I can walk? Oh. Ava Dummers. Look at the pattern we're doing in 1 and 2A. We're using our constant rate for both of them. What is our constant rate? 10 over 5.53, or like Blake was saying earlier, what else could it be written as? Yeah, it could be written as 1.8. So when we want to find it in 600 seconds, can't we use our constant rate to do that? So how could I write that up? 10 over 5.53 equals x over 600 seconds. So we can cross multiply this. Or, Ava, like you were just telling me, what is the other way we can do it? What is our other way to write our constant rate? 1.8. And that's meters per second. So I can multiply that by what now? Yeah, by 600. Whatever way I want to write it and solve, they're both the same answer. So when I multiply this, or if I'm cross-multiplying and then dividing, both times I will get 1080 meters. Let me see my calculator. So let's leave it as 1080 per meters, 1080 meters for 2B. And let's go on to 2C for now. It says, how far could you walk in 1 hour? In 1 hour. Well, again, like I did before, I'll tell you that this 3,600 seconds. 3,600 seconds is 1 hour. So, what is my constant rate of change again? Lily, what's my constant rate of change?
10 over equals x over 6,000.
Yep, 10 over 5.53 equals x over 3,600 seconds. What other way could I write it, Lily? I'm going to just write it the other way. It's the shorter way for us.
1.8.
Yep. Awesome. 1.8 times 3,600. And that gets us what, Elena?
6,509.
Is that what it gets us? 6,509? Hold on. Recalculate it. 1.8 times 3,600. Only Elena should be talking right now.
Oh.
6,480, right? That's what you got? Okay. We got to make sure we're typing these in the calculator right, or it might slightly give us a wrong answer. Meters. Right, that's why I had us do this way. We're going to just stick to doing it this way. Yep, our 1080. Yep, times. Yep, you could do that too. So if we're using our 1080 from above, and we're sticking to 1.8 times 3,600, it gives us 6,480. If we go on to 3 on the back page, it says describe in words the distance in meter you could walk in a given number of seconds. With your shoulder partners, and your shoulder partners only, if you don't have a shoulder partner, work as a table. Describe to one another the distance here. I'll give you about 3 minutes to discuss this, and we'll come back together. Can you guys describe to me what you wrote for question 3? Someone from your table? I'm sorry, the number, the rate, I'm sorry, say that again?
So, depending on how many meters you want to walk,
Okay.
you multiply that number of meters times 1.8.
Yes. Exactly. Thank you. So basically, like Maria said, the walking rate per seconds that we found, which was our 1.8, we're going to multiply that by the number of seconds that we walk. So you would use the walking rate per seconds and multiply it by the number of seconds you walk. Perfect. Thank you, Maria. So now for 4, now that we know we explained it in words, I want us to explain it as an equation. It says write an equation that represents the distance, d, in meters that you could walk in t seconds if you maintained this pace. Well, we know our constant rate of change. So Robert, what would I write for this?
D equals 5.53.
Okay. Times t. Why 5.53? What's my constant rate that I use? 1.8. Exactly. Thank you. Times what again? T. So that's really what we were doing on the front. We did 1.8 times 30 to get how far we walked in 30 seconds. We did 1.8 times 600 to see how much we walked in 10 minutes. We did 1.8 times 3600 to see how much we walked in 1 hour. We did all of that. We found that our constant rate of change is 1.8, which is what we use. So we can plug anything in for our t here to find that. So in 5, if they said use the equation that we found right above that we just wrote to predict the distance you would walk in 45 seconds. Well, how would I solve this, Joey, on using our equation? I have d equals times 45. Awesome. So when I multiply this, Joey, do you have a calculator? What do I get? 81 meters. Awesome. So does everyone see how we've been using that pattern of keeping our constant rate of change 1.8? Sometimes we were doing 10 over 5.53. I know we all found that using 1.8 gives us a more accurate answer, though. So we'll stick to that right here on the back page. Going on, in the summary, in our equation, the distance is the product of the walking rate and the time. So D equals our R, which is our constant rate, times our time. And we wrote it out right here. R equals the walking rate, T equals the time, D equals the distance. Then it says time is the independent variable. That is the independent variable. D is the dependent variable. How far I walk depends on how long I walk. If I only walk for 5 minutes, the time is going to be different, right? Depends on how far I walk or how long. Either way, however you want to say it. Let me move this up here so you can write that down. I'll give you a couple minutes to write this down. Here are the homework questions. Page 16, numbers 1 and 2. That's it. Just questions 1 and 2 on page 16. And these are due tomorrow.